Good evening, students and class. I hope everybody is doing well. I'm going to start the lecture for today, which is Tuesday, 4/21/2020. And the topic that I will be discussing tonight or here at the Canvas. And let me just go to the Canvas and open up the topic here that we will be discussing. Tonight we're going to be discussing shell scripting in general. Some of the syntax we have already discussed within, like, for example, function calls and other shell scripting methods using if statement, while statement, for statement, case, and other stuff as we did in the past. But tonight is a continuation of the same syntax, and more examples, more syntax will be explained as we go. And then we add on to the same kind of concept of scripting, because the topic of this class is learning bash scripting. So I'm going to show you tonight command line shell scripting, as well as actual writing into a script, the same commands that you write. Normally you put it in a script which you could be using VI or Vim or any Emacs, any other editorial that you love it to use. You could just use it and script it, and then change the permission, make it executable, and work on it. That's as simple as it is in a basic form. But as we go through the procedures and the explanation, you will learn a lot more than that. At this time, I'm seeing a lot of the students fully. Thank God it's everybody is doing good, and everybody is logged on. People that they are not logged on, they can just continue on the lecture and continue trying to communicate with me over emails and submitting assignment and projects. That way I know you're doing well, because if you're not authenticating at the same time or coming online at the same time that the class is, I'm expecting you to listen to the videos and do all the lab activities, as well as assignments and projects and midterms, so we are not falling behind. Please make sure that you're staying on top of your homework and projects as well. And if you have any questions, please send me an email, which I read my emails. For the projects, some of you have submitted, some of you have still not submitted the projects. I'm still waiting for everybody to submit it. If you have not submitted the midterm project yet, please make sure that you finish it by this Thursday, the latest, because if I start grading, and if I don't have it by next Thursday, then you may lose the point for that project. So I'm giving it enough time for everybody to make sure that they complete it. Due to the coronavirus, we're a little bit more flexible in terms of time, but you have to start working on it. Can't wait for all the projects to the end of the day or the end of the week or the end of the semester, unfortunately. So at some point we have to get it done. Thank you so much. So I'm going to cover first command line shell scripting. And to do that one, I'm going to open up CentOS. In this case, I'm running Ubuntu and CentOS VMs. So I'm going to go to the VirtualBox called my Linux CentOS. I'm going to log in. A little bit slow, but it's going to come. Well, this one is coming in the process. And let's see if it's unusually slow for a VM. Let me make sure that if this one is running, we could use that one for a little bit. And okay, so I'm gonna just shut down this one. For some reason it is hanging. Let me go back to the Linux, see if this one is up and running. Yes, it's up and running, so we could just open a terminal. And the reason I have the icons a little bit bigger than normal is just so you can see the screen better. Some of you might be looking or listening at the videos afterward on your cell phone or something, to just sit somewhere, wherever you feel comfortable, and listen to the lecture. It would be nice if you can see the font of what I'm typing. So I make it a little bit bigger. That way it's more readable. You can listen to the lecture using a cell phone even, or laptop or desktop or any other device, portable devices. So at this time, I'm running Linux CentOS, and the version that I'm running, as you can see, etc OS release is showing CentOS version 7. And if I just clear the screen to make it look better, I could say hostname Ctl, and that also shows me the same information where I typed in and uname -a to show that one, and then the etc OS release. Hostname Ctl is a Red Hat or a CentOS version of command list that it will just come up with Red Hat 7 and CentOS 7 and upward, because they have system D. So there's command like system Ctl, name Ctl, and other related. I'll cover a lot of those one as well. But I'm showing you, for example, on this machine, that my host name is localhost local domain. So if I just type in host name by itself, it will show the same thing. And then this one is nice because it shows you the virtualization. KVM is the kernel virtual machine that was built on this one with VirtualBox. And then the operating system, as you can see, is CentOS Linux 7. So there are some details of it, like, for example, the kernel belt 3.10.0, that was showing up on the uname -a, which is right here. Uname -r, sorry, uname -r could also show you the revision of the belt version. So, and then the architecture x86 is also right here. It shows that. For example, this one is showing the version of the kernel belt is 3.10.0, 1062. 3 is the major one, and then 0.10 is the minor numbers, and then 1062 is the build from Red Hat or CentOS. ELF is Enterprise Linux 7. x86 is the architecture. So if I just type in uname -a for architecture, I mean for all, it will show, and uname -m will show the machine type, which is x86 in this case, and there, and uname -s will give me the system name, which is, and this one is Linux version. So you could get all that information running this hostname Ctl similar. And then at the same time, there's other files and configuration that you could check. But why I'm showing you these commands, because what you type in at the command line, all you're doing it on the scripting, you're taking your commands list to run it, and you're just gonna execute it inside of a script. But inside the script, you're just putting some condition matching, some kind of sequences that you go in a certain order the script has to run, and then it has a certain selection, which is the if statement, the select statement, and all those case statement that it does a certain comparison, and then there's iteration, which is looping. Remember at the first day when we taught you how a computer program is constructed, it has those three main components, which is sequence or step of commands that you just put it, and then inside the commands you do certain condition matching, which is your selection sequence. So the selection is if statement, case statement, and then there's iteration part, which is the looping, while do statement, for statement, until do statement, and many other different looping condition depending on the programming language or the scripting language that you use. In this case, we're using Bash. So if I just want to know my Bash version, I type in bash dash version. That would give me the version name. So let me clear the screen and type in bash dash version. It will tell me that the version of Bash is the GNU version 4.2.46, which means that as long as I am writing a lot of the commands in the Bash, they support version 4.2, meaning it's the latest version that nowadays is running on Unix platform 4. If you have version 3, an older version, which is coming with the older distribution, maybe you need to just upgrade your operating system as well as your Bash, and as well as a lot of application tools that you need, because it's time for your system to be upgraded. Otherwise, you may have a lot of security issues later on and you're not aware of it. So it's good to just upgrade the system. And with Unix, when you say that cat etc OS release, if you just do that one in your version 7, 7.4, 7.5, whatever version you have, then you have this command called yum upgrade. And if I just say yum upgrade star, it will just do the entire operating system. And if I just say yum upgrade as a such process or SHD, it will just do that package or RPM. In this case, it's just that package. But yum upgrade has a lot of tools, and last time we did mention what yum is. Yum stands for Yellow Dock Update Manager. Is basically the there's two tools that you use. One is yum and the other one is RPM, Red Hat Package Manager, RPM or yum. And these two tools are your friends to download and install packages and upload and build something on your system. You just use these tools to search for packages and install packages and upgrade things like that. There's a lot of ways you could do those ones, and I'll show you how to look at the repository, how to download every one of them. But at this class right now, I'm trying to teach you how to do shell scripting from command lines. So let's say I just was doing that command uname. So if I just clear my screen, I could just say uname -a followed by pwd. As well as running this command uname -a, I want to see my print working directory. So I could say, well, just add another command called ID. So I want to see my ID also. And then I want to see, let's say, a semicolon, and then say, run the who command. And then put another semicolon date. So what I'm doing there is just basically running as if I'm running all those commands from a script by putting a semicolon at the end of the command, meaning press enter. So the steps that I want to do, since I'm running the uname minus a first, in this case, it's just going to do in that order. And your script, when you're writing a script, you're putting in the sequence. If you want PWD to be running first, then you just have to put that order. So let me just clear the screen. Let's say I say host name, followed by host name CTL, followed by let's say uname minus S for system. So these three commands are running. The first name is host name, which is right here, is showing the host name. The second command is host name CTL is giving me all this information. And then the third one, uname minus S, is gonna be there. Now the sequence of commands that I'm executing there is going to be in that order because I told it so. Now if I just wanna say uname minus S first, and then run the host name command second, followed by the last line, host name CTL, followed by echo end it. Let's say just a word. So all I'm doing is that this time I'm running uname minus S and then host name. So uname is there, local host is there, and then the last command after the host name CTL end it. So that sequence was done. Now the semicolon is just a terminated end of line in this case. So it tells the bash script, I'm not inside a bash script, but I'm inside the bash shell, and the shell knows that how to execute each command in that sequence that I'm putting it because of the semicolon. So now watch, if I just change the same command, and instead of putting this to an Boolean AND statement, that means run this command uname minus S and run this one and run the rest of them with the semicolon, because those other ones have semicolons. So now watch, if I just change this one to an OR statement, then in this case, it's going to run the first one. That's a short circuit in programming that it just says, if this is true, or the other one is true, or the other one, since the first command succeed, it should give me either one of those ones, right? Either this or that or that or that. So it's going to execute. Now I'm going to just change these ones to OR statement, all of them, from semicolons, saying that either one of these commands run these. So watch, the syntax is that since it ran the uname minus S in this case, it just did not have to check for the second one because I did not have semicolons. Now I'm going to change this one to an AND statement, and then change this one to an OR statement. So now watch, because I'm saying that run the uname minus S and also run the host name, then it's going to do that. But these other ones are OR, that they don't have to be true values. So I could just say similar to this. For example, if I say touch this file, now I just created the file this. Notice the permission of a file because of the UMask. Whenever you create a file, that it looks for an environment variable called UMask. The UMask in this case is set to the octal value of 0002. These last 3 digits are determining how the permission of a file like this that I just touched, how they should be created. So the first 3 characters is 6 minus 0. So because it's 6 minus 0 is 6. So if I go to the basic calculator and I just type in 666 minus 002, is going to give me 664. So that 664 is, this is the permission in octal value, meaning that this is 4 plus 2. 6 is a read write, and this dash means this is not set. The next one is also 4 plus 2, that's also 6. So 6, 6 is the next one, and then the other one is, since the last bit is on, or is readable, then it's 4. So how that is determined, because 2 to the power of 0 is 1, to the power of 2 is 2, to the power of 3 is 7. I mean, to the power of 0 is 1, to the power of 1 is 2, and 2 to the power of 2 is 4. So R is 4. In this case, I'm going to quit out of the basic calculator. Now watch, if I just do this file, I just told you that because of the UMask and my general for creation of the file, it looks for a permission of 666 minus the value of the UMask, and is going to get the permission of this. So no matter how many files I touch that, it always create the same permissions of read write for the owner, and then and group, and then other people only can have read access, which is 664. So if I change that number, let's say I'm going to change that one, change mode to 666, which means everybody has read write, nobody has other permission for both this and that, those two files. Now if I just look at this and that, those two files, I just changed it, but notice that I did not do the one for, because I put on the this, and I forgot to say the word that. So this is, that. Now both permissions should say that are read write for everybody. And that was 666. Now I'm going to change the same permission. This time was 664. That's exactly what the touch command did. So now if I just look at the permission of those two files, you can see that it's exactly there. So what I'm showing you here is that when you create a file on Unix, whether you use VI or cat, or you could say Hickel, this is a line 1, and then send it to redirect it with this greater sign to a file called dat. I just updated the dat file. Even though the file existed, this greater sign just created it. So each of these commands could be a command that you put it inside your script as a sequence of a step you want to do. But later on, I'm going to go to the for statement. You could do the select statement from command line, as well as the actual scripting. So we're getting there soon. At this time, just understand that when I'm just creating that file, I did this file created. Now I see the size of this file is 17 bytes. And if I just look at the file called dat, and that's the line. If I just want to see the line number minus n, it just showed me that line number on it there. Okay, so how am I going to print that one? You could do many ways. For example, last week when we discussed print command, you could do a set command, a stream editorial with a P for print, and you just see the content of that file. But notice that when I do that one, since I'm not suppressing the lines to just show, not show duplicate, it might just show 2 lines, which it did. And that's, there was another syntax with the set, you just do -n to suppress it, and now you only see 1 line from it. So this is another way of the looking at that file. If I just want to see, for example, echo less than sign, and then let me do this. Let me this, and then cut that. Sorry. So this one is reading the input file, and this one is telling me the file descriptor. How do I know that file descriptor information? Because on that device, the word cut, that is actually showing the contents of it because I'm redirecting it here. So if I just say file dev fd and then 63, there's a file and the proc file system or the file system that it says this is a process, a file cannot open no such file or directory at that time, because this one was just at the time that when I did the echo, it just appended, created that one, and it's gone now. This is not similar to the proc file system. This is a file descriptor for it that it existed. So the file descriptor, when I'm talking about proc file system, so for example, if I just type in ps command here, ps, my bash is pointing to this a process ID. So if I just say ps $$, and then it will just show the same number. Or if I say echo $$, it will show the same number. But notice that under the proc file system, I also have a $$ for that process ID. And there's a lot of commands in there that are basically handling my bash. In this case, if I just want to see the command line, this one, you see that file is there and it's 0 byte, but because it's memory based proc file system, I could just say cut that one and it will tell me that I'm using bash. And right here you see that it shows that it's bash. And that I also know it from here, typing in here bash. So if I just go to another bash session, and then just open up and I type in. Now notice that my bash session this time, echo $$ is pointing to there. And if I just do the same thing, earlier it was showing that number, right? Now I'm seeing a proc file system of $$ CMD line. And if I just that one is no longer, proc is this. Now it's the same pointer that is doing it, except that one forked another child process. So how do I know that one? ps minus efa grep minus I bash could tell me that these are there, and one is being the parent process ID of the other one. And the other one is just the child process. So this is the child process, and these are the parent process IDs. If I just do PS by itself, you can tell if I just go, for example, PS minus I, EFA, grep minus I 1, 2, 2, 3, 4, you can see that my parent process ID for this number 1, 2, 3, 4 is 11,497, and 11,497 is right here. So if I exit out of that one, then I just do PS. Notice that now 11,497 is there. This process is no longer there. And now if I just do, let's say ls minus l / proc / command line, I just see it now, and the process ID changed. And then if I just cut that one, it is still saying that this is bash, because that's what that is. If I just go to another shell, that would say corn shell or whatever shell I'm using it. Okay, so at this time, let me come back to the example of this and that file. So we created this file called this and that, these two files. And we were just running the commands to do this. Now, if I just want to check for existence of this file, if that file is empty or the file exists or the file is having read write permission and so on, I could do a lot of if statement here. One of the short form is that you could say something like this. If the file is that exist, this is meaning that run this command, let's say cat that, run this command cat that if the file exists. So it's going to check between this condition of the brackets. It says dash f means if the file that is a regular file, ordinary file, then ampersand ampersand meaning that if this one is true, then run this other command. This is what ampersand ampersand means. The other command is cat that. Now it's going to show the content of it. And if I just change that one to say ls minus ld that, it will just do that. So it's so simple to just check it. Now, if I just want to say, if this file is readable, you could just say that. And if this file is executable, which is not going to be true, then if I just look at that one and say this file is executable, list it, it will not list it. So it just gave me the prompt because the first condition failed. Echo $ question mark in this case is 1, not 0, because the first condition did not match. But if I just change that one to say if the file is writable, then do that one, it does list it because the file is writable. And if I just say echo $ question mark, now it's going to say 0 because it is successfully, and the first condition was true. Whenever a function return a result, that means that status is true, successful. Whenever it's non-zero, it assigns between 1 and 255 different numbers. Any of those numbers indicate that the command was not successful or a failure, the last command. So at this time, let's say I'm just looking at that one and I just say, was this one executable? No. So it did not run it, but now I'm going to change the permission and I'm just saying u plus x. This time I'm not using the octal numbers of, well, I could do like 755 and then just make that file executable. And now I just change it to read write executable. I gave the same permission that it was there, but let me just change it back to what it was originally 664 that. So at this time I just said this is the permission. I could do change mode u plus x and then that. I could just do the same thing. Now I made the permission of the file read write, and then since I did u plus x, only the user I give permission. If I want to give the group permission, then I could say group permissions. So now notice that ls minus l that it gives the group permission. Let me change it back to the 444, and at this time I want to give everybody the execute permission. So plus x, you don't specify user or group or other, O for other, U for user, and G for a group. If you just do plus X, it will just do it for everybody. So now I just gave everybody executable permission. Now if I just say that syntax of earlier, where we say if that file exists listed, it will do listed because the file is now existed there. So another thing that you could do is, for example, for variable declaration, for example, you could look for certain thing, and inside this file, cat minus n, if I just change this one and say cat minus n that, and then at this time, I just want to see if rather than using the word that twice, I could put it into a variable. I could say file name is equal that, and then echo $ file name just be the same as that. So I could just change this one to dollar sign, and then file name. And then right here, if I just do it like this, it still works because that is known as the file name. But I want to use a variable file name because sometimes you want to create logs and other ones in your script and you want to manipulate it within one variable. So on the top, it's more clear of writing programming to just write on top of your script a variable like a log name or something, and then reuse that one 10 times. And whenever you modify your script, you don't have to modify them 10 different locations. You just go on top of your script and you just update the file name from whatever it was to something else. So at this time now, I'm going to do the same thing. It does exactly there. Now, if I just want to see this variable, if it is empty or string or something, then you could just say if, let's say, a dollar sign, you could say -n dollar sign file name. Okay, if this is the case, then you press enter. This syntax of if statement is a little bit short form, the commands that I used previously. The new ones, it's a little bit longer because you're going to a second line of prompt. That greater sign is the PS2 in Unix. Normally that one is assigned to a greater sign telling the user, go ahead, I'm waiting for more input. Since I use the F statement normally the default syntax is if some condition, the condition you put between this left bracket, right bracket, and then whatever condition you're checking, you're putting that statement. As long as that statement and that condition becomes true, that then part will execute. So if I just say then at this time, if the variable is not empty, it will execute the next command. Did somebody want to say something? Okay. So now if I just say echo the dollar sign, okay, file name, in this case is not empty, so it basically does that one. Then else is the section where you just want to say if that doesn't become true what you want to say. So I could say echo the variable is not defined. Okay, so then I could say that, and then now because I started with the F, you just reverse the IF to FI, and then after that one, now it understands that you're done with this statement. So if I just press enter, it says that, right? And now if I just go for a variable that doesn't exist, now let's say I just change the same syntax and I just put one line here, or just put something like if this file, this variable doesn't exist. Now, if I want to say this, then do this, else this does not exist. Now it's going to say the, and then variable was empty. So it just, even though it was that variable was defined, it was not just having any value. At this time, you have this -z option. If the string is empty, then you print it. So if then you could say if not string is not empty, you could do a negate of that one. Now it says the variable is not defined or the variable is empty. You could just change the syntax of that if statement, and instead of this, you say else the variable $f is empty. Since it's empty, it will not just say anything with $f. So in this case, to make your syntax a little bit looking better, you skip the $sign with backslash and you just say the variable $f is empty. because that variable is actually empty. It's not assigned values for it. Now, if I just say f is equal file name, and then just say echo $f, it will just do that one, echo $. This is whenever you use the brace, it is always recommended to use whenever you're referring to a variable to use the $braces and then the name of the variable, close the brace, because it is getting rid of the ambiguity. Sometimes you might put a directory structure and you are done with it, but then since you are missing one character before or after, the bash script does not know what is that variable name. So whenever you're doing with this syntax of $, and then brace and then variable inside there, this is much better syntax than this syntax without this, because if I have another f after this, this is not gonna do it. Like for example, let's say I do this, it's gonna say file name f, right? But if I just do it without that one, this is not gonna work. So imagine if that syntax was slash this, and I say file name dot text. So this would actually do it, but if I just did not use this one and I just did it like this is going to fail. If the $f at this case was somehow interpreted because maybe I had another extra character like that before, now $ff is not defined. So what I'm showing you here is that a little bit more clear command lines or a scripting syntax that you have to follow. Those are rules of writing clear script to make sure that there's no ambiguity on the script somewhere in the script at all. So what I did in there, I created a variable and then I checked it for the if statement and the other one. You could also do if statement in comparison of like for example, if 2 plus 2 is equal, let's say you could do is equal 4 and then echo yes, else echo no if I. So at this time it says no because it does not understood this if statement too many arguments. So at this time bash scripting, it says either put it within a different syntax or try to put it into 2 brackets. And then at this time it did not understood that one because the plus and this. I'm going to try to do this. This is another syntax of shell, and at this time I just compared it, right? So depending on what syntax you use, you have to look at the valid syntax for each one of them. Like for example, if I do something like echo 2 plus 2, it's going to say that, and then now I pass that one to a basic calculator, I could just get the value 4. And if I just say get the 4 plus 5 and then do that one, and notice that if I just do this one and then do at the same time the multiplication is the wildcard, so it's not going to work with that syntax because you just are telling it echo 4 star. 4 star means like this. If I just say echo star is just everything that's on my system on the directory, or ls minus l star is that one. So why that syntax failed is because you're just using the wildcard that was there. So you have to skip it to say I'm actually using the multiplication rather than the wildcard character. And the same thing, if you just go to basic calculator, you could do the same kind of manipulation. You could say 4 plus 5 plus 5, and then times 10 minus 3 divided by 2. So when you do something like that calculation, now it's the order of the precedence is happening by the system, disregard to how you put it in the bracket. But if I just say, make sure that you do 4 plus 5 first, that's the parenthesis takes the highest things. Then multiply it by 10, and then minus 3, and let's say minus 3, and then divide by 2. So now I get a different result, because what it does, 4 plus 5 is going to be 9, times 10 is 100. Times 10 is 90, and then 3 over 2 is 1 something, and then 1.5, but because the floating point is not done, so it is there. So now if I just change this one to a 4, that becomes 2, then I should get 88. That's how it is. And if now I want to just change the order of this one to say the order of this one is there, I'm still getting that, because the division is done first. The parentheses are done first, and then the multiplication is done second, and then the minus is done last. So at this time, what if I just want to change this one and then minus 2 times? Obviously, I get a different value, because the first thing that it does is 4 plus 5 multiplied by 10, that's 90. Then it does 4 divided by 2 is going to be 2, times 2 is 4, 4 minus 90 is 86. That's how it is calculated. So you can also, on basic calculator, you can also add up numbers that are floating points, like 4.5 plus 5.3. So you could get that one in that order. And if you want to do a different scale for it, you could say a scale of, let's say, 3-digit. And then at this time, I could say the same number, 4.5 plus 5.3. And you could get scale is equal 3. Okay, let me just say scaled. Okay, scale. Did I type it? Maybe the scaled word. Okay, let me just see one word here. I'm gonna quit out of here and go to CS. It's building a script. Building a script. Okay, I'm going to look for grep minus I scale from start of the search. My basic calculator done search. Okay, I'll come back to the basic calculator scale and why it's not working with a certain scale value. It should do that. Okay, let me just go back to the syntax of okay. At this time, I'm going to show you some of the, actually, before I go to the actual script, let me do a little bit more. I'm going to plan to do till 7:30 more scripting from command line. So other ways you could do from the command line, we were just using if statement. You could do a for statement. For example, one of the command that you could do in the for statement, you could say for variable name, which you could say for v, for variable n, certain numbers. Let's say 1 through 10. And then you're going to say do print $v, and then done. So at this time, I did not understand it because I used a print statement. There's no such thing as print statement. Either use printf statement or echo statement. So let me just modify that one. Okay, I'm gonna do echo, and it will print it there. So let me clear the screen. I go here, and that's an example of a for statement. Now at this time, if I just want to do this one, and instead of this to A through Z, it will just do all the alphabetical. And if I want to just change it to A through Z in uppercase, similar, I could say A through Z is the same thing. So another way I could say for fruit, for F and for fruit, let's say, and I could say apple, pear, grape, orange, do, echo, I love the $ fruit. So you could say that and then close the bracket and then done. So you love all of them, but what if you just only like one of them? You could just say, for example, in here, where it says the statement, you could say do, let's say F, okay. At this time, you're gonna do comparison of strings. So you have to put the string within quotes, $ fruit, and then is equal, and in all languages, you're gonna put equal as $2 because you're not assigning assignment statement. If you put one, normally it says that assign this variable to this this value to this variable. But in Bash scripting, you don't have to do that one. Bash is smart enough that it says, well, this in this case, you're just assigning, comparing it. So I'm using within this if statement one $= as meaning that if they are the two words are the same. So if I just say, in this case, pear, grape, let me just say I love pear, okay? And then I just say then echo I love, I love and $ fruit. And then else, you could say echo yummy, $ fruit. You could also, say whatever you want to say with it. In this case, and then do fi. Now I'm done with the do statement. I'm going to do done. So yummy apple, and then I love pears, and yummy grape, and so on. So at this time, you're looking at a string comparison, the if statement that's doing a comparison is using a $, fruit compared to pear, and then so on. And if you have to write this one in a Bash script, just copy each line and modify it. And now you have modified that script. So let me just do another for statement syntax that you could see how you do a different syntax. This is like a C line, C kind of syntax, C programming and C++ in Java. Some of you have already done that one. So the syntax of C programming, it says for variable name is equal initial value and then semicolon. This is the first expression. Then you're saying that evaluate that first expression, saying for variable is equal 0, and then I less or equal to 10, let's say. That's another expression. That's the condition that has to become at some point true. Then this time, when this condition is true, you're not doing infinite loop. Otherwise, if that condition never becomes true, then your loop will just go infinitely and it's not good. So you have to have a condition that makes the condition of the for statement true. And this is the expression that you're putting. So how you make that condition to true is this incremental. Because I'm initially assigning I is equal 0. Now at this time, I just have to say, incremented by I plus, saying that increment the I to go to the 10. Once it becomes 10, it does that comparison, then it it's going to do it. So at this time, if I just do this one, notice that it told me that syntax is incorrect because that's a C syntax. So on a C syntax, normally C programming language, you start something, you do something, and then you close it here. You do your printf statement or whatever other scanf statement or fprintf, whatever syntax that you want to just do a string copy or string manipulation, you're putting in there. But at this time, I'm not putting the syntax of this. As soon as I press enter, even if I put this syntax, it's not going to understand. The actual syntax is do, then some statement, and then done. So that would be the proper syntax. But because I'm using the bash, I need to put these two in two brackets. So that becomes a condition that is going to get manipulated. Now I have a do statement here. And then I say echo, and line number is, and then you could just say $I, and then done. So it will just say, I'm sorry, no, but not percentage I, $I. We're not on Windows. Windows for variable declaration, when you're doing it, you're using a percentage, variable name percentage. And then Unix is only $, and that will do that. So at this time, I just printed those numbers, right? The nice thing about this one is that within the for statement, you have some sort of iteration that you say how you want to jump into the number of I. So I could say I is equal I plus equal 2. Notice that I'm jumping 2 digit. So all I have to do is here on my incremental, I could do it 3 and jumping 3 digit. Okay, so if you're a programmer, you're writing a for statement, you could manipulate it however you want to just go to within the iteration, how many steps you do. And bash, they come up with something called sequence. So if I just say sequence by itself, sequence of 5 and 1, just providing one number is going to give me a starting point of 1, ending point of 5, no different values. You see that? 1 through 5. But if I say 5 is starting and 10 is ending, let's say in this example of above, we use 1 and then 10. So now it's going to just say 1 and through 10 printed. That was my first for statement. And now if I want to just do that one within an iteration of 2 in between, I could do that. An iteration of 3, So there's an initial steps, sequence one, start, how many by incremented, and then ending it. So within that for statement, I could do the same thing. I don't have to do that. Okay, so I could just change my for statement now to use the sequence command. So instead of here, I could just say sequence 1, 3, 10. That would provide the same one. But notice that if I do that one, and now I'm using two double quote, it does not understand that. So what it does, I need to take one of them out and try to do that one. It's still not understanding it. So how do I execute it? Now I'm going to put that one as a dollar sign and execute it. It's still not understanding it. Let me try to bracket here. Sorry. Oops. I'm sorry. To bracket here, and it's still not understood. I'm going to make that one with backtick first. There's a syntax of backtick to see if the backtick works, then I will work on the other one after. So this is the backtick, saying that for sequence 1, 3, 10, do echo that one. It is not understanding it at all. So for, oh, the reason it's not doing it because I've missed a variable. The variable $i was missed. So for I, N, and then now it's going to work. So here, if I just change this one to 2, it's going to work. So now let me just go back to this original syntax. Here I put for IN, then just change that one to 2 bracket, 2 parentheses, and that will do it. So when you're doing it within the syntax, remember if I just do PWD here, it just says that one. If I just say echo $, PWD, it is the same thing. Okay, I could say run any command here. I type in who, I will get it. Type in ls minus l there. So now at this time, if I just say ls star.text to just show only the text file, I could do that one. But at the same time, I could also change that one to a backtick. That would do the same thing. So I could just say within a for statement, for example, I say for file and backtick ls star.text and then say do, and then I say echo the file name as $, file, and again the parentheses is, in this case it is not needed, but it's a good idea to write it when you're writing a script. So I'm going to do ls minus ld $ file and done. So why is it just failing? Because when I started the backtick here, I did not close it. So that's why I need to just do the backtick up there. It is waiting for my backtick to be closed. And unexpected end of line command substitution. So let's see what it does. For file and ls minus l do command substitution and expand in the file while looking for matching that double quote. Yeah, there's no double quote there because all I'm doing is when I meant the backtick, I put double quote there. So that's what basically says working on this file, command line is this, and then it lists it as we go. And I think we could do the same thing with the while statement. So let me just give you examples of while versus for. For statement is you're using with iteration. You could increment the iteration, and you will be setting some values, and you're matching within the for statement some condition. And when that condition become true, it exits out of the for statement. Otherwise, the for statement and while statement is dangerous if you never terminate it. Because, for example, the syntax of while statement, let me clear, it says while some condition, and this condition initially it has to be true in order to just execute this command. Do, and then some statement, do some statement, and then after this some statement, now make that condition false. So that while does not become true, then done. At this time you will terminate. Okay. So if I just run this one, obviously this will just fail because that's not a syntax there. But now let's just say x is equal 1, and then I say while $x is. Notice that when I'm doing a comparison of numbers, I'm using this equality symbol rather than the other one. The other one, equal sign, the equal sign symbol is saying that it is a symbol for comparison of a string. When you're doing comparison between numbers, you have to use the dash equal for equal, dash not equal to not equal, greater than, less than, and so on. So in this case, I'm saying while $x is greater than 10, then do something. This time do, what am I going to do? I say echo the value of $x is. The value of $x is, and then $x. I can just change that echo statement to a printf statement and make get a little bit more easier to write the syntax because echo and printf both are very powerful, but with printf it has more functionality in terms of adding strings and getting certain formats with tabbing it and putting line space. Although echo statement has all of that, echo statement does not have, for example, formatting of having line indentation of left indented or right indentation and so on. You could do that one with floating point numbers. You could print out certain ways with printf statement. We will do some of the examples in the past. I might have shown you when I did already with awk and gawk and set syntax. So at this time, let's say the value of $x is that, and then if I just say done here, this will just go infinitely because I did not just say when to terminate the script. So how I do it, like if I just say this, okay, $x is equal 1, since that one was actually greater, I had to do less than because x is less than, so it enters. This one has to be true in order for my while statement to continue. Now, because I did not do any incremental of the value of x, in this case is going to go infinity like that forever. It will never terminate. So that's an infinite loop. In order to get it out, you could do Control C. And if I trap the signal and trap number 2, there are certain signals that right now Control C is seg entrap, which is an entrap number 2. So if I say in my script trap this, and then put either seg interrupt or I put the number 2, then it's going to not even allow the user to terminate it with Control C. And then you have to do a kill -9, which is signal interrupt 9, or kill -15, terminate it, that's seg 15. Seg 1 is a signal hang up. So normally you want to just respawn a process, you do seg 1. If you want to kill a process, seg 9, kill -9. So at this time, I'm going to change my for statement. And before I do that one, I'm going to say semicolon. And then the next line, I'm going to say increment x plus plus. Notice on the bash script, you could just do as simple as that to increment it. And then just say done. Now I printed out all those ones and then I compared it. So at this time, I'm going to do another while statement. Let's say for while, let's say x is equal, I'm going to say 10. I'm going to go downward, okay? So I say x is equal 10 if not x, while $sign x is greater than 0, do, I'm going to use the printf statement, printf, and then I'm going to say the value of percentage d and the value of let's say the value of x x is percentage d and a new line character, and then I'm gonna just say $x while x, okay. So it is doing that, and then say at this time I'm gonna decrement it. I could decrement it doing that x minus minus like that, sorry, minus minus. I could do it like this, or I could do it with this one, x is equal, I'm gonna use the expression $x minus 1. And that's an expression with the backtick. I'm using the expression, say, give me the value of x and subtract 1 from it, put it back to x. The other syntax was much easier, much shorter. But the old style, you could use the expression to do calculation like that. So now I'm going to do a done. And then notice that at 10, 9, 8, and subtract it, and it went downward. So that's the while statement. There's another one called until. On C programming language, the until statement was not there, but it was a do until condition. So if you're familiar with C programming or C++, in opposite to while statement, you would have used a do until. But in a bash script, it's called until do done. So the syntax of until is until this condition is false, do statement, and then done. But before done, you're gonna make that condition true. So first, initially the condition is false, and then that's how you enter the until statement. But until is saying that until that this condition doesn't become true, execute this statement. So sometimes you're writing a manual or something, you could use the while statement, you could use other ones, but it's more cleaner to write the until statement because you don't want to just do go to an infinite loop of while true condition and then break out of the while statement when that condition becomes true. You want to just do this something like this, it's much easier to do until condition. So let me just do the until condition. I'm going to say x is equal 10, and then I say until this condition is telling me until $x initially is going to set it to false. So until x is, let's say I want to decrement it, so I say until x is greater than, less than 0. 10 is not less than 0, so that is false. And then I'm going to say do, and then use the printf statement again, and I say the value of x is %d, new line, and then $x. So I did that one, but now I'm going to have to make that x to be true. So since x is equal 10, now I'm going to decrement it. I'm going to use the symbol of x minus minus, and then do a done. So what I'm saying there is with the until statement, I'm saying that when initially x is less than 0, that's false. So it's going to fall in that condition. Then later on, once it print 10, 9, 8, so on, until 0, it is going to be true at 0. Then minus 1 is going to be less than 0, then it's going to exit out. So that's the answer for the until statement. And then until is good because it is going to execute the statement at least once. So if you want to print out a menu, it's good to display the menu at least once to the user. Okay. So there's a number of other things we could do, comparison if a statement, all these statements within the script. Like for example, reading a variable from the command lines. So I could say while read var do echo $var and done. At this time, it's just waiting for me to type in a variable. I could say this is going to just echo back this. I could say this is a test, is going to say that. If I say end, it's going to there. Whatever I type in, whatever I type in, it will echo that. So it just basically is like a kind of like a echo statement in this case. You are doing that one, but at this time it's not terminating, right? So now if I just want to see, for example, cut that file. So if I just want to say a file that I have that, I don't have a file that, I'm going to create a file that, say for I am, and I'm going to say, let's do the sequence. Or I could say for I n range of A through A dot Z, I'm going to say, or 0 through 9, let's say. 0 dot 9, I'm going to do, and I say echo, and this is the line number $I, and at this time I'm going to use double greater sign because I'm going to say I'm going to create the file dat.txt, and then I say done. So now I created the file dat.txt, and it has those lines in it. Cut minus n dat.txt. Line 0 has, line 1 has line number 0, and so on. Each line is one letter off, right? If I don't care about how I did it, that is okay. But if I just say this one is gonna just say if the file that.txt exists, then say bin rm that.txt. I just deleted that file. First I checked it that file existed. Now I delete it. Now I'm going to just change the sequence. This one, I'm going to start from 1 to 10, just if I want to make my file. Even though I could have just recreated what the one greater sign earlier, and I could do that one. It's a number of ways you could do certain things. So now I have it. Line 1 is matching to line number 1, and so on. So at this time, what if I just what I wanted to show you about the for statement we went through, while statement, do statement, do until. Okay. Oh yeah, with the while read var. I wanted to show you the while read var. So if I just say cut that dot text, and then I could say while read var, do echo $var. At this time, I'm not, even though I'm echoing that line by line, I'm not gonna just go to infinite loop, because there's a start and end on that file. It will just do that. So the while read var, I could say while read var do echo $var, and then done. And then this one, I could read the file from here also, saying that instead of cut that and pipe it, I'm redirecting it with less than sign. So that's another way you could do redirection of that file with as an input. While read var. If I just say while read var 1, var 2, var 3, and then I say echo do echo $var 1 and $var 2, and then $var 3. Okay, so if I just put this one now and say inside here, I'm going to say one input, this. Okay, it's going to just only echo $var, and for var 2 is empty. So my first argument, $1 is var 1, $2 is var 2, $3 is var 3, $4 is not assigned a value. So if I just give one argument, it does not know about var 2. If I just say this is, now it's going to say this is, because var and var 2 is assigned. And if I just say this is a, and it's going to say all three of them. But then now I'm going to say this is a test. Notice it's going to just print var 3 with a test. Because no matter how far I go, it's not an array, but it $* is assigned to var 3, the rest of them. So it's exactly duplicated, right? And if I could just say for each one of them in my var statement, where I say echo, I could say var 1 is equal, var 2 is equal, and var 3 is equal. Now notice if I say this, it just says the value of var 1 and var 2 and var 3 is missing. This is now var 2. This is a now var 3. Now this is a test. Now var 3 has all of that, rest of them. So this is a test, and that is also assigned to var 3. It will just say var 3 is equal the rest of the information. Okay, so a lot of ways you could do scripting within the command line. And normally when I'm doing system administration, or I was doing it in the past maybe 30 years of my life doing this kind of work, it is just basically allowing you to do a certain string manipulations of command line. So normally I would work on the processes and look for the system CTL, let's say unit dash files. I could just say system CTL list dash unit dash files. List, I typed it wrong, list. So some commands that you do, and they say, for example, say status of firewall D, let's say. If a firewall is running or something, you normally check to see if firewall D is running and what is the status. You want to see if it's SSH D is running, if Apache is running. All these processes, you can enable them, disable them. I will go through system CTL commands in general. For example, you could do something like, if I want to see the show all the system variables within the SSHD that are defined. If I want to see the actual services for it, I could say cut. And I could go on those ones under this directory user lib system D, and there's a SSHD variable that are written these syntax here to say how I should invoke the startup processes. If the process dies, what should be running. Like for example, user sben SSHD, if I go here and then say grep SSHD and grep minus v grep, it will just tell me that this is the daemon for SSHD running as a daemon that is listening for connection. So the SSH line could be connecting. The etc, normally etc SSHD is there. Here it says this, this syntax might not be accurate because it might be etc sysconfig SSHD. Yeah, it is actually there. So if it is there, you could just say file and sudo and then $sign and bang is sudo this. Now I'm going to type in my sudo privilege. Yeah, it is a text file, so I could see the contents of that file, sudo cat, and you will see that exactly all the environment variable for it, that whether you are allowed to start the accession or something, and then how you people are connected with what privilege, the ciphers, all those ones are defined there. Okay, so it's 8 o'clock. I'm gonna go to some of the scripts at this time, because part of the commands that I'm doing here, I'm not gonna stop at 8:05 for the lecture, because I need to cover as much as possible for examples. A lot of the students are not attending the session while I'm doing it, for whatever reason, maybe internet connection or maybe busy or something. I need to go through the labs, and I'm going to expect you to use these examples that I will post at the lab yourself as well. So I'm going to cover a lot in the labs as well, because I want you to maximize your learning ability by listening, by looking at the video, and with the tools that are available, you could practice it as well. I'm hoping that you have at least a virtual box or somewhere that you can practice these commands. Okay, so at this time, let me go to some of the script that I prepared for you. One of them is called s1.sh. As you can see, let me VI it. VI s1.sh. Script 1, basically, that's what it stands for. I'm going to go to line 1. On VI, when you go to line 1, you basically press escape, shift colon, and type in number 1. It will just take you to the first line. So in this case, I'm using bin bash And the reason I'm using bin bash is because afterward, all my syntax is the bash syntax. So bash version 4 earlier, I showed you that we're running. I could even check for inside VI by doing this exclamation mark, which bash, and it tells me that it's a user bin bash. So whether I type in bin bash or user bin bash, it will understand that one because the bin slash bash is either symbolic link to bin bash or user is bin bash. So let me just show you another way you could verify that one. You could do type -a bash, and then you see that now I have one is a user build bin bash and one is a slash bin bash. So what you type in there, it's in either case is going to work. So that's simple. And then later on, I'll show you these ones. I'm using the env command and then passing the bash as the interpreter as an argument, which is a better way dynamically. You're not forcing it with hard-coded syntax. So it's better to use user /bin /env and then followed by bash, Python, Perl, whatever other programming language or shell script, corn shell, whatever C shell that you're using, you pass that as an argument to env, which I will show you on another example. So normally whenever you run a shell script, the name of the script is assigned to $0, the first argument. The argument, the first $0 is the base name of the script name, the actual script name. So $1 is the first argument to your script. $2 is the second argument. $3 is the third argument, and so on. And $@ is the array of all the arguments that you passed on. $pound is the number of arguments that you passed on. I covered that one last session when we were talking about it, but I'll mention it again and again so you understand all those ones with more examples. This time, let's say I'm doing a script name, and there's a syntax on bash. It's called base name. So if you have the user bin bash, if you type in the base name, which I'm going to do again right here, I could say base name bash. You could see that it is showing this as the argument, but it's not putting the /bin in front of it. It just gave me the actual name of it, base name, okay? So at this time, if I just want to see another syntax of something else, I'm going to do this. The reason I'm doing this, because sometimes you pass on with full path of the script. I only want to know what's my script name. If the full path name of the script is ~CS018 building basic script / something, I only want to know the name of it. So then that way $0 passes argument to the base name, it will just say exactly the name of it. If you put a /s1.sh, it will still say the name of the script is s1.sh. So it is going to take the trailing parameter path information out of there. And that's a good thing to do. So here I'm just saying the name of the script is and the name. And then I'm running a uname, so ID. These are simple commands that I was doing earlier within the command line. But now I'm passing it as I'm doing the echo command. Notice the echo command, you could put the syntax of backtick inside here, or you could use the syntax that we did earlier with the variable name, or you could do even pass it the way we did with $sign thing. So if I just want to see, for example, don't use this backtick, let me just run it first time, make sure that it runs, say s1.sh. Notice that I'm running s1.sh, and then it does say a script name is s1.sh. It is, even though I'm doing it /, the dot slash base name is removing this, and it's $0 is this $1 so it's I'm getting the script name as this $1 here. And then the host name and all the other information, user ID and group ID, all the commands are showing here. The date is, and then the users is showing W So if I just do users here, it's going to say that's what the users are there. I might be like logged on with one session, and then I'm having my group ID also as W. Okay, so if I change that one to, let's say, echo, remember the syntax from the command line, users, this one is going to just say that. Now, if I just change that one to this syntax, saying that put it within that group and then run that command on it, it's going to do the same thing. So my vi is $1.sich. I showed you the backtick with the date command. I'm going to change that one to $, this. So there's two forms of running a command within another command. So in this case, either I'm using the backtick, the date command, or the $ bracket parentheses, and then followed by the command that I'm doing. So if I run it as $1.sich, it still says the same thing. See, the users are there. So both syntax works. Now, if I want to see the syntax of each one of them, I could say set minus, bash minus x, and then bash minus x is $1.sich. It will just run each command as it runs. It's in debug mode. Okay. So what I could do is, and I could do a vi as $1.sich. I could just put right here, I could just say set minus x. And then initially, I'm just saying, as you run each command, just show me the output. So let me make this one a little bit bigger. That way, clear screen, it's $1.sich. Notice that on each command, that as it goes, it is running the who command, and then it gives the output. Running the echo, then the output, echo, output. And then right here, for example, on the users, run that one and it give output. So let me go to the base name. Notice that when base name was run, the syntax was this. Now the script name is just taking that $1 because this one was passed to $0. Okay, I want to show you something like that. vi, and let me say copy is $1.sich to $t.sich, temporary vi $t.sich. In this case, I'm just showing you the base name by itself. This is script runs on the host name. So right here, I'm going to delete every one line of here, and just for clarity. So now I'm calling it T1, and then clear T1.sh. Notice it says base name T1, and then the base name is T1.sh. Okay, so I'm going to just modify it T.sh, not T1. So let me just take the debugging out. So it we only see the output T and $.sh. It says the name of it T.sh. I'm going to modify it again. This time I'm going to not assign the base name here. So if I just did that one without the base name and assign $0 to that, I don't need to run a command here. Whatever the $0 is passed, I'm going to assign it to the script name. This time, if I run it, it's going to say /. Watch, this is T1.sh. It's going to say the script name is there. So if I just do this, if I just say this full path, okay, copy it, and then paste it, and then /t.sh. It just says the same thing. So notice how tedious is that one. Even though sometimes you do need to know the actual script path name, but if I just change that one to vi to t1.sh, let me do this t.sh. I'm gonna show you both examples. This one, I'm gonna now say, take this one out and then run this command after. Okay, and then say after update using the base name, the script name is. Okay, so if I just do the same thing and then get two output t.sh, one with base name, one without the base name, I run it. I want to run it with the long syntax. Notice that the first one, it says the long syntax because I did not use the base name. Second one is just giving me that. So if I just use this one and I say this time I'm going to run it with /t.sh, it's going to say t.sh, the argument that is passed. I'm passing it like that, and then it's going to do this. If I say tilde slash CIS. So let me just see if there's an easy way to just type in the command, okay? There. So now I know that that's my PWD. And instead of putting this long syntax like this, okay, I want to just say PWD and then after that one, tilde. So can I just do this? Backtick PWD backtick /t.sh. Yeah. So you could do that one, or you could just say p is equal, and then backtick echo echo pwd. Since now p is assigned to that, p is assigned to that, you could run, and sorry, not echo this one. You run the command pwd. Now p has the value of that. You could even do something like this, $p followed by t.sh. It's exactly like that. So you don't have to cut and paste. If you, that was an easy way from command line, you cut and paste on your commands. Okay. So let me see what other script I have for you. S1 env, vi s1 underscore env.sh. This one, basically this one is going to do the script name of the script is stored in $, and the simple script to do base name uname minus a. Okay, this one is doing env, or the users are both. Maybe I'm modifying the wrong command. Let me see. More s1 underscore env.sh. Okay, I'll just modify this one, vi s1 underscore env.sh. So I want to just run the env command instead of one of these commands. Uname minus a, let's say I'm going to run env here, and then echo the environment variable or. So this is a list of all the environment variable, and before this one, because it's a long list, I'm going to say pipe it to more, and then I say at the same time echo pause echo press enter key to continue, and then a read pause. So I could just wait for the user to just type in s1 underscore env dot sh. Now, when it prints the print, the env, basically it's waiting for me to press one page at a time because I did a more on it. So now I'm going to go next line, and at the end of it, when I see all the variables and their values, as you can see up there, it says press any key to continue. I'm going to press enter key to continue. Actually, not any key, enter key to continue, and then it's going to go to the next statement. So vi. Our next example is $2.h. Okay, this script will print the environment variables using env, set env, and print env. So on Unix, you can print the environment variable using env, set env, and print env. Set env is to set the environment variables. Print env is to print it. And there's also set command. Set command also. Let me add a set here. Set. So if I just go out of the this one, I just say by default, if I want to say my environment variable, I'll type in env. Env and print env are much the same. They are system variables, as you can see. For example, if I want to see grep path, that environment variable path is there. LD library path is there. Oracle ID is there. A lot of the system declared variables like login name, like GNOME version, the display is set. All those ones are basically defined here. Whether you do print env or print env or env, they give you the same output. Set, on the other hand, is more customized, more user-defined. So set has, in addition to the global variable or system variable, set also has the local variables, user-defined variables. Like you say x is equal 4, that will be just assigned as a local variable that you just cleared. So in addition to the global variable, this the list of set is a lot more. So and the way you do it, normally, when you set a variable, you say set x is equal 4, you say equal $x, it will just, sorry, set x equal $x, something is wrong, set env, sorry, not set. So set env x is equal 4, and then at this time, because I have to be on a C shell, and that's how you set that variable. So let's see if C shell is there. Yeah, set env x is equal 4 or 5, doesn't matter. Now $x will have the value of x there. So I could unset x and then echo $x is no longer set env, because I set it with x. I'm sorry, let me slow down here. I use the set env in C shell to set a variable. I'm using the unset env and C shell to just unset it. Okay. So now I'm going to get out of the C shell. I'm going to go back to the bash shell. So if I just want to do export a variable called x is equal 5, and then equal $x, is going to say 5, or just say x is equal 4, and then echo $x is equal 4. whether I use the export or just regular one, it will be done. But the difference between export and regular ones is sometimes you want to use export within from one shell to another shell. You want to create global variables. You could use the word global versus local. If you want to use a variable inside a function and you want to export that one, you could use the export, but it's better to use the global argument in front of it. And normally, when you're inside the function, it's a good practice not to modify global variables within the scope of a function, because you are going to lose the value in the first place, and it's not good to not recommended to modify inside a function for global variables. Normally inside the function, as soon as you lose the scope of that function, you lose the local variables that are defined on that function. So global variables are not supposed to be modified inside the local variables or local functions. So in this case, I'm doing an export, and then I could say unset x, and then echo $x, it will just say undefined. So the unset is going to work for bash with a command of x, and then to get the value of them, you could say set x, and then let me just say x is equal 4, and then say set grep minus I. Well, let me just make a different variable name. I'm going to say export name Wahid is equal, my name is Wahid. Doesn't matter. Echo $Wahid, and then I say set grep minus I Wahid. And as you can see, that is a local variable that I just use it within this environment. So set sees that one. If I just say env and then look for grep for Wahid, it's not going to show because that's all system variables. Normally on the system variables or on etc profile, etc dot tilde dot bash rc tilde dot conch rc dot login dot logout dot profiles. All of those dot files, you could define your variables, and then system variables or on etc profile normally, and then etc related files. So if you look at the etc profile, then it shows you any other profile.d, for example, that has all the profiles, and then for the users, there's under their .bash or c .bash history and .c shell .vim rc and all other ones. So there's a number of them that you can look .login .logout. If I look at the etc profile .d, that's another list of all the shells, whether you're using corn shell, C shell, a lot of the language, for example, language.c shell. Let's say if I look at one of them as a lang.sh. Normally notice that there's one for C shell, one for Bourne shell. sh is normally by default is Bourne shell. And then the author of the Bourne shell was Bourne. I think was James Bourne or Jack Bourne, his name was. But that was a long time ago. And then later on, they come up with Bash, GNU, and the developer of Unix developers, all of them, they thought that, well, we should come up with the enhanced version of sh, Bourne shell, as Bash. And they're using it. It's really good. Bash is really very good tools, a very good interpreter. It does provide a lot of good utilities inside there that they could be used in a lot of syntax. But however, Bash is still born again shell. It's still young. This is version 4. Later on, maybe when Bash grows up, they might use Z shell. Z shell is similar to Bash, but a lot more enhanced, a lot more functionality, a lot more features. So think about the Z shell, Z shell, ZSH. ZSH or Z shell is the last alphabet characters, Z. The authors thought that maybe by the time Born shell grow up, maybe they are gonna just use Z shell because corn shell, C shell, TC shell, Born shell, all of them have certain features that are already built in on top of it. That they add on more features with Z shell that is not with any of the other previous shells. So it's good that we could maybe teach another class with Z shells, yeah, and that would be nice. At this time, let me just cut that file, the language.sh, more. So you can see source is equals 0, and then the language is comparing it with a lot of other syntax, a lot of variables. And then sometimes if you forget the syntax of certain a statement or certain variable declaration, it's good to look at these profile files because it does a lot of the system declaration and manipulation. It will actually tell you a lot of details at the system level. I was playing around with a lot of these ones back in when I was developing on or writing programs myself as a software engineer with different companies. Sometimes I had to write program in C, sometimes I had to write program in Unix shells or database with Oracle and Formix, Sybase, and other stuff that we played around with our work every day, Python, everything, Perl. But all of those ones, sometimes you look at the syntax and you say, man, all this is the same. It's just the syntax, somebody decided to do it this way, but the concept is for all of them are the same. So it's not kind of like an issue. Like right here, you can see that this ESAC statement that you can see, it is a case statement, and these are the pattern that they're matching for it. A lot of the syntax of it, once you learn the basic of what a FS statement does and how you do comparison, whether you do it in one programming language or one shell scripting or Bash, Python or something, it is all the same. So it is good that you're practicing with this, and I'm hoping that some of you guys are working as admin somewhere to do more administrative, and I will show you some more as we go. And I'm hoping that you guys could come up with questions, as well as if you feel like something that I did not explain well, or you need to understand it better because you're doing it on the job, just send me an email, say, Professor, can you just explain this area of Unix, or this area of scripting, or this area of programming? I'm more interested on this one because at this time, even though on the class we're trying to cover as much as possible with both scripting as well as command lines and syntax and all that things, I'm interested also maybe on the graphic part of Unix. Then I could just explain that one on a session better. That way I could meet the needs of what you're looking for. But please understand that I'm not going to just come up with something to say this particular user wants to do this one, and even though the rest of the students are not interested, I will just have to have a session allocated to that one. I may allocate a session for it if I see more people are interested on some subject. But if nobody is interested and only you are the only one, I'll respond to you to your email, and I'll help you out individually. So let me go back to the next script here. 831. Script number s2 redirection. So vi s2 underscore redirect such. Redirect you can do many ways. Piping is one of ways. Greater sign symbol is to send it to a file or to create a file. That's another way. Double greater sign is to append it to another file when the file already exists. So you're not overriding it, you're appending it with double greater sign. And then in this case, these files are just creating the same commands that are showing env and sending the output to env.text and print env, print the output to print env.text and set to those. So we can compare these numbers. And then after that, when I say the difference between the env and print env, as you can see, I'm comparing env.text with print env because both of them are system variables that are defined. There's not that much different in comparison to and one of them compared to set commands, because set has a list of local variables, so the list is much larger. But print env and env are brothers and sisters in some ways. The difference between env and set, you can see this one is more, a lot more. That's why I'm running the command with more to see the list. And then it pauses to see the list better. At this time, I'm doing like ls minus ld, so you can see the size of the file for each one of them. And then I'm doing a word count. Word count command on Linux or Unix. You could do some of these commands that I'm typing works on Mac, OS X, Unix, Solaris, Unix, any Unix version that you could name it, AIX or let's say HPUX or DEC OSF1 or Sun Solaris, and then BSD. It could run on FreeBSD, on Mac OS X Darwin, and as well as all Linux version, Ubuntu, CentOS, anything, OpenSUSE, Caldera, anything that you name, Red Hat. So at this time, word count has two arguments or three arguments. One is dash minus L to give you a long line numbers, how many line numbers on all of those ones. If you put 10 files in front of it, it will give you the line number on all of them. If you get the star.text, it matches all the star.text. And if you use regular expression, it understands regular expression syntax. So in this case, I'm saying that give me a long listing of all three files that I just created with the greater sign file up there. And then the second line, it says, give me a word count. How many words on each of those files is there? Then minus C for how many characters. So minus L for line number, minus W for word number, number of words, and minus C is for number of characters. So if I just exit out and say s2 underscore redirect .sh, run it, you can see that it shows the difference between env and print env is just one line that are there. One is the actual command env, and the second one is print env, the opposite. Everything else was so much the same. And then if I press this one, now it's showing the contents of it with the next command. So I better run this one with bash minus x command. So bash minus x. This show me the commands as well, and that it's getting executed in debug mode. So now you can see that this was the different. This time I'm saying read pause, and it prints out the list of env, and then later on print env and then set is longer. So at this time it says press enter to continue, and then the number of lines, I just passed the number of lines here. Okay, a little bit slower. Okay, I have to go really slow here. Yeah, the word count minus L, it shows you that 46 lines on the first two, and the only difference was that one of them had a print env and the other one had env. That's why they're both 46 lines. There was not that much difference. Set was 70 lines. And then now you can see the number of words. Both of them had 47 on the first two, 78. But then the number of characters, because print env is a little bit longer than the 5 extra characters, this print statement, that's why this is 9 and the other one is 4. And then the set is text obviously has a lot more, so the number of characters bigger. And we did a comparison of def command with the two, and that way you know exactly what they are. Let me see what other script I have here. So S2, S3, vi S3.sh. This one, they demonstrate the use of the for the following two commands. So we did a number of these commands at the command line, and now it is showing the same kind of commands. You could do it with using backtick and this format of $ parenthesis followed by command followed by the parenthesis. And this script does basically those one. And you can see right here, I'm using the backtick, and then here use backtick. Here I'm using the command syntax and $date and other ones. Pretty simple commands, the list of the files or ls star as, and then this one is just basically nothing but showing you two different way that you can do, either use backtick or just the output are showing here. The current directory is there and so on. So if I just look at the s3.sh, it is either you pass it with a backtick or the other one. So inside here, it's just basically a list of echo in this case. It's not much that you're doing, but let me see what other thing I have. This was S3, S4, view S4, .sh. Okay, the demonstrate the use of Unix pipe examples, or so in this case we're using the pipe symbol, the less than sign symbol, the double greater sign symbol, and the usage of less than symbol. And even though I only use file to clean all files, I'm expecting you to look at the contents of these ones and question yourself whether you know the syntax, how would you do these things, and that way you can understand the detail of it, why I'm doing it this way. For example, right here, I could have just only created, deleted file3.txt, and I could have just say if file3.exist, then delete it. And the rest of the append, since I'm using the one greater sign, I don't need to just delete them. But I wanted to demonstrate with the find command, you can just look for any file that has whether file1.txt, file2.txt, or something. You put one question mark. Question mark means one character matching this. I could have put file 1 and then use the regular expression 1 through 4 like that. Would that work also, because find is matching the pattern recognition of the regular expression. So at this time, I'm just showing first, I'm saying cleaning up these ones. But if I run the previous run, file 3 and other ones would exist. So I didn't want to concatenate the file and the file keep growing. Whenever you use the greater sign, it's going to overwrite to the file that already exists. when you use a double greater sign, it is going to concatenate or append to the end of it. So if you're running this script over and over, then for every subsequent run, the file contents is going to grow because you're using the double greater sign. So and either you have to clean it from your script, which I'm doing it here. I'm going to search for find, and then first I list them, and then this ls minus l with the exact command is going to list them, and then a minus ld is just showing content of the list, not if it is a directory, it's not looking at the directory subsequent files. And then left print braces, right braces is like begin and end. This backslash semicolon is just saying like a enter. Basically, you could put a backslash semicolon or just a plus. It would do the same thing. And then this time it's going to wait sleep 3 seconds so I can see my output for a little bit, 3 seconds, and then it's going to this time remove them. I want to say, yeah, this file was created and now I'm going to remove it. So the first time maybe they're not there because I run it the first time and already clean it. And then every other time that I run it, the same script will be there. And this one example of the pipe. So I'm running a RPM command, Red Hat Package Manager. Minus QA means query all. A Q stands for query, A for all. And then grep minus I open SSH. I'm looking for open SSH. But then after that, I pipe it to a head minus 3. I only want to see the first 3 lines. Output is shown below. So this is just, I'm going to do an echo, but this output is shown below on my actual command is not there because that doesn't make sense. That's part of the echo. I'm just showing you here what my echo command is. And then the output is going to show and then do another pipe query, open SSH. This time I do a head minus 1 because I want to only see the first one with open SSH. I want to get more commands on it. So how I want to see the content of that package or RPM, I do minus QL, L for listing, query listing, and then the variable. So this time, and then I want to see a tail minus 2, only the 2 lines, otherwise the list is so big. And then and the next time I'm going to just do the same thing query, but I want to see only the binary file, like SSH key, gen, or something that are there, all those binary executable files. And then, so this one is an example of using the greater sign. I use the yum search to look for a package called SQLite, and then the SQLite, and then I send the output to SQLite the information. So right here, the SQLite yum search SQLite is going to search, and then the output is written to the SQLite. And then at this time, I'm also appending something to the same command here, saying that this is the last line that was appended by echo command to SQLite.txt using double greater sign. And then more examples with other, so right here, I'm creating this file, the second line, I'm appending to it. And then here I'm catting that file, contents file 1 and recreating. So this cat command is basically creating work like similar to copy command. File 1.txt greater sign file 2.txt. Another way to do the same copy command, you could do cat file 1.txt while read var, and then echo $ var, and then double greater sign file 3. Basically, I made a duplicate of those files. Now, the number of lines that are there, I'm looking at each lines to say, was my copy or cat or something had any distinction between each other ones? Did I miss anything? I'm doing a comparison and line by line numbers. And right here, it lists the files. And then concatenate all files. At this time, I'm going to concatenate more than one file into a file 4. So file 1, file 2, file 3 is all written here. I'm missing file 2 here. So file 2 here, appended all to file 4. The number of lines in file ZOR. Now I'm doing a search of word count with a regular expression 1 through 4, and then sleep 5 seconds. Then the number of words, how many words are there. I do the same thing, but this time using one question mark. If file 10 was there, then it was 2 letter. I had to use asterisk or a question mark, 2 of them, or just put like an 1 through 10 plus pipe it by the bracket, and then either plus or asterisk, depending on 0 or more or 1 or more of that occurrence are happening, as we discussed last time. So on this one, let me just run it. So I'm going to clear the screen as for the other switch. And notice that this one cleaning up from previous run, it waited 3 seconds, but now it's giving me a press enter to continue. Because this file exists, my remove is going to remove it. And then the head -3 is just doing that, and then goes on. And at this time, all the files are created and everything. It's a little bit faster for looking at the output. So let me change the parameters for each one of them. And instead of doing this, although you can see the number of lines, for example, file 1 and file 2 had 2 lines and so on. I'll just, when this one is done, I'll change the sleep vi as 4 and $h, and then sleep. Let's see, sleep 3, 5, 5, 5, 5, 5. Okay, so let's just make sleep 5, change it to sleep 10. Even though it's a little bit long than that, but I will do it for now. 1 to $, and then substitute sleep 5. I want to just change that one to sleep 10 and globally. So that changed all my sleep statement from first line to line 10. I'm going to run this and clear the screen, run S4. The first one, 3 seconds is okay because we don't need that long. So now it's running the head -3. The first 3 RPM are showing here. And then the next one is going to show the our gen. And at this time, all these ones I want to wait 10 seconds. So file 1 through 3, you see my copy command, my cat, it all did exactly. They are the same size. The content of the file is the same. File 2 is the same. Working on the content of file 3. So you can see file 1, file 2, file 3 are the same. Line 1 and 2. Now it's going to just say concatenation. So file 2, 3, and are all there 2 lines. So when you put it on line file number 4, it's 6 lines. 3 plus 2 is 3 times 2 is 6 lines. And then the number of files. For example, the number of lines here, 11 for the first 3, and then 33 because summation of that one would be the 33. And then the number of characters, 63 for the first 3, and then summation of it as 189. So you can see it is perfectly done with copy command, with cat command, with while read command. All of those ones were, whether I was doing concatenation or string manipulation. Let me do a copy S4 and .sh to a file called tt.sh. temporary, bitt.sh. I want to show you another method of here that, let's say, all these echo statement, I'm going to put a line number, set and u. So now notice that these line number are kind of like, I already did some formatting with these while statement, for statement. But if you just don't do any kind of formatting initially, or mtt.sh, I don't need to do that. Let me see, cat s2.sh. Okay, so there's no f statement, for statement, cat s5.sh. Yeah. Copy s5.sh. I want to show you a thing just for formatting. It's good to know how you could just use the vim to format certain things. So assume that you're not having any format on these lines. Do, and then nothing here, nothing here, nothing here, and nothing here. Okay. It's good to indent it, so for clarity, it's more readable. Your code is more readable, it's better. But I want to just show you, if you decide to work on somebody else's script and you just didn't like the way they not use any indentation, rather going by line and modifying it and updating it. So let's say you had a script like this. Good thing I just made a backup of the script and call it TT. So I'm going to just use this as an example to modify it. So at this time, I just say, well, I don't know where the done statement for do is where the done statement for this one is, and so on. I could just write some kind of readability. So let me do this, set and u. And you can see the line number. So at this time, I want to keep these pound this line number. So starting, this is okay, clear is okay. Starting at the do right here, do to done. These two lines, rather than doing manually, I could say escape shift colon. I could say 16, 17, substitute, and then the anchor, which is the first character, is saying that if the line starts with, every line starts with the first character of it is anchor, meaning that, and dollar sign would be end of line. So in this case, I'm going to say substitute that one to do done. I want to replace it by 4 characters. So it would be at least matching 4 space towards the done. 1, 2, 3, 4. I could do that, and then I say grep. So now I shift that one is there. Then I'm going to come back here, this do, and then this time the if statement is there, but let me just do the same thing with up to here. So do to 24 to 35. I could say 24 to 35, substitute the anchor to 1, 2, 3, 4. And then that is done. But now I want to shift the if statement, which is 26 through 33. So then I say, what is 26 as shift, if statement, and 33 is fi. Substitute the first character again. I don't have to put exactly if there, because I know that the first character I want to shift it there. So that's easier to know. I could just maybe even use tab command to just tab it there. So and instead of giving 5 space or 4 space, I could do that one. But if I want to just do 4 space from there, I could say 1, 2, 3, 4. And then I could just say that, and then now it's there. So let's say I just didn't like that one. I wanted to tab it. I could say escape, undo. It just puts it back, and then I again do again. Say 26, comma 33. This time substitute it from this to either one space I could put, or maybe tab. So in order to generate the tab, on some system you could press the control. I mean, at the tab, it will just do the same thing as control V and then control the tab afterward, pressing the tab. That is just generating the combination of character that should generate a tab inside the BI. Then I say do it globally. Now it tabbed it with that much space. So if I just want to do set a list, notice that these ones has a control I character, meaning that they're tabbed. This one is a space. So most of the time, these non-visible character, they're there. It is still going to work. So if I just say that tt.sh, it's still going to work the way we want it to run. See, the script is running. And this is done in a sequence. I'm going to go to the actual script afterward to show you what I'm doing on that script. I was just demonstrating the example of store.sh. What is was it S4? Yeah, so this one is S4. S4, I'm doing that one. This time I'm just looking at not the TT, because I already showed you how to indent and how to multiply. I mean, how to not multiply, and I'm going to show you how to multiply now. This multiplication is just showing, for example, within a for statement. In this case, I'm using the for statement and see like syntax, but notice that I'm using 2 parentheses there. That's how a for statement is gonna run. And then within the do done, I'm doing some printf statement for each of the variable. As I'm doing printing the variable like I, which is initially is let's say 0, I is equal for I. In here, I'm missing a 0 there. Okay, so go modify it as for.sh. So right here for, wait a minute, which one is it? S5? Oh, it's 5. So vi is 5.sh, and then set no list, and set no nu, and set no list. Okay. At this time, I'm gonna just do this for statement. That's what I was looking for. For I is equal 0, I less than 10, then do that. Okay. So let me see, make sure that my second for statement, if there's any, and this is while statement, and this is while statement. Okay, we're good. So clear the screen. S5.sh. And then notice that this one, the multiplication of 1 and 1 is there. I'm just adding the numbers as you go. For the first one, it says when 0, 0 is equal 0, 0 times 0 is 0. and 1 is 2, 1 times 1 is 1, and so on. It goes all the numbers, adding it, and then as well as multiplication within the for statement. Then it's waiting for me, say, okay, 10 times 10 is 100, and 10 plus 10 is 20. So it finished all the 10 numbers. Now it's going to say the value of I is 10, counting down. This time it's doing a while statement, going downward. And then it goes back again here. After it becomes 0, it just says take off. So it was just writing those words within the while statement, and it was decrementing it. As we discussed earlier, the while statement, initially the value is set true, and then later on the value is set false. The until statement is the opposite. Press enter to continue. Okay. The value of x is 2. Notice on this statement right here, within the while statement, I'm saying that if the value of x is equal 4, then I skip it. So this is the part where I want to show you on the if statement with this. Let me just clear the screen. More is $5. So right here, taking off, counting down. Here, if you see that I'm doing a if statement within the while statement, so you could do something like that, and it says if I is equal 0, just keep saying that, because I'm from down to 0, I only want to say when it is 0, it's take off. But other than that, I just say counting down and decrement it. Once it becomes done, then it says you're done with it. In this example, while statement that I was saying is skipping with equal 4, I'm just breaking out. I'm not using break a statement. I'm using continue. Continue means if x is equal 4, just skip that 4. Go back to the outside loop and continue on with the next iteration, which is 5, 6, 7, and so on. So that's how it is going to check for the rest of them. But a break, I would have put a break here, and this one, it would have break after 4. So the 4, it will just go to the outer loop and will not continue with the rest of them. Continue saying that, yeah, you could skip that number and then go to the outer loop and then continue with the rest of the loop. A break would break out of the loop. More S6.sh. What is S6? To demo some example for the statement with sequence and fallocate. Fallocate is really nice command on Unix sequence. I already showed you. If you look at the man for sequence, for example, remember the for statement I was showing you, there's a start, there's a incremental, and then there's a last that you just customize it. Here, they made it that way. So if you just say sequence of 5, the last number you provide as 5, it automatically prints 1 through 5. And then if you say 5 through 10, then it's going to say 5 as first, 10 as last, and then it's going to print only 5, 6 through 10. And if you say start with 5, increment by 5 up to 100, then it will just do that last. So for example, let me just show you sequence 5. We did that one, sequence 5, and then 5 to 10. This would just print 5 through 10. And now if I want to say go to 100, it will do that. And if I just say increment by 10, it will just go by increment by 10. And if I just say increment by 15, it doesn't matter what number I go, it will do that one. The sequence that you do, it has to make sense to you. Maybe if you just say 33, 5 plus 33 is 38, the next one you're 71, the next iteration is already past 100. But within your for statement, I showed you how you already increment that one. So sequence is one of those, one on the script that we were just doing this, more six. So sequence, and then this command also shows you if allocate. File allocation is sometimes you need to create file on the fly on the system within your for statement or the sequences statement. You could just generate thousands of files, and you could just give it any initial values, and you could delete them and so on. So at this time, I'm going to show you from command line before I show you from this script. I want you to understand what I'm doing here first. Let's say there's a need for you to make a directory called temp2. cd to temp2. I don't have any files here. And you want to just say, I want to use some find commands to say, I want to list all the files that are bigger than 10 megabyte or 1 megabyte or 1000 megabyte or 1 gigabyte. But I need to have some demo files in order to tar up these files, back up these files. I need to have some data to play with. So on Unix, you could just create your temporary files. There's a lot of ways you can do it. One way is the fallocate. Fallocate -L, and then -L for listing of the size. And we could say 10 megabyte, and then say file 10 meg. Let's say I just create a file called 10 meg. If I just say ls-l that file is there with 10 meg. How do I know it's 10 meg? If I say disk usage -s for summary and human readable sh, it will say it's 10 meg. And if I just want to create the same file, this file with 10 kilobyte, I just say 10 kilobyte. And now I just do this ls-l. You can see disk -sh star, it will just give you the size of the file. One of them says 12 kilobyte. That is because in Unix, sometimes depending on how many blocks is allocated for it, it will just say a file that is really small, you will not get the content of it. For example, if I just say greater sign t.text, I just create this file t.text, which is 184 characters. So if I say disk usage -sh star.text, it just says 4 kilobyte. By default, the minimum that the file is showing there, it is actually 4 kilobyte or 2 kilobyte or 1 kilobyte. That's how much is read in blocks. But if I just do octal dump -c star.text, I could see that 184 lines, including all the new lines and all the other ones that are there, any new line characters, but it's all in there. And if I just do a word count -L star.text, it does tell me this 4 lines, how many words are there, 29, and how many characters, 184. So at this time, I'm creating more files. Let's say, for statement. I could use my regular for statement, or the for each statement. Let me just clear the screen here. Do a pwd ls. I'm going to clean up everything here, so I just don't have anything. I'm gonna create files, say for file, and I'm gonna do sequence of let's say 1 through 100. I could do it like this, or 1000, doesn't matter. I could just say create that one, and then do a do, and then say echo creating the file um, $sign file sub I $sign $sign creating the file underscore this. Okay, I'm gonna just create that now and say f allocate minus L minus now I'm gonna give a size, so the size would be $sign file, whichever size the size, and then make. I want to create it in megabyte, 1 megabyte to 1000 megabyte. The 1000 megabyte will be too big, so let me just make it in kilobyte. That even 1 kilobyte is 1000 is going to be a gig file. That is big. So let me just stop this one. I'm going to change this one to 100. And then that way, creating this file now, and then say f allocate minus L, and then $sign file. I'm going to create in kilobytes, and then file name, file $sign file dot new. I could name it anything I want, so it would be just that dot new and say done. So it's creating each one of those. The 100 files are created. Now they are there. And then if I just want to do a disk usage minus sh and summary, you could see that this is a lot, right? But what if I just want to go outside here? Now I do disk usage attempt 2, and then that's 5.1 meg altogether. And there. So if I just say on this one, find dot minus name star dot new is gonna just say did I create the new in uppercase? Okay, and new. It is just creating a listing all of those ones. And if I wanted to say yeah. So if I just do minus name, and then what if I want to say find a star from the temp2 directory, temp2, and then I want to list all of them. But now what if I just say minus size is 10 kilobyte only, and only shows the file was 10 kilobyte. But if I want to say plus 10 kilobyte or greater, it will say this. And now I just want to say over 90 kilobyte, only those ones. So that's the size. If I just say minus 90 minus, let's say 10, then it shows the first 10 of them. If I just want to say show me only the 5 kilobyte, then it's going to just do that. So if I want to see something negative than that, it's going to say show below that one. If I want to see a plus, it's going to show all the ones that are matching big. So that's a way of the size of the file. Now, if I want to say instead of kilobyte, or show me the megabyte, none of those files are megabyte. None of them are in gigabyte. So now if I just go to the temp directory temp2 and just say allocate minus L and then say 1 meg, not 1 meg, let's say 1 gigabyte file, 1 gig, and then I'm just saying 1 gig file. If I just did that 1 gig file, I just created that fast, and then that disk usage minus sh 1 gig is gonna say 1 gig file. Now this time if I just go back to my find command, and then since I'm already there, I could just say dot, I don't need to do these ones, minus name star, it's gonna find it. So now say 5 gig, not 1 gig plus, it will just say, and then let's say 100 meg plus, it's gonna just report one file that is at least 1 gig, not that many. So if I just change that one to 95 or 97, and then it's gonna print the last 4. 97 meg, let's see, 90 meg. Oh, that it's not meg, it's kilobyte. So the plus 90 kilobyte. Let me see. Maybe the size that I created or there. Minus 5 kilobyte. And take the minus out. Dot slash. Okay. And then now I'm gonna say to 90 and plus 90. Yeah, plus 90. So if I just say plus 97, that would show the last 4 that I was looking for. I want to just see any size that are bigger than 97 kilobyte. And then since those are the one, if I have attach a file with 1 gig, if allocate 1 meg, let's say, or 10 meg, let's say I do that 10 meg, I go allocate minus L 10 meg, and then say 10 meg file. Now I'm going to just change my 97 to megabyte, to megabyte, but how many? 1 plus, it will just print it, anything, and then that's 10 meg. 10 plus will not print it, but 9 plus will print both. And then if I just want to see minus exec less minus L listed for me, it will just do the same thing. Right here, a minus L semicolon, it will just do that. So running this command will just print it. And if I just did this syntax, remember I was saying whether you use backslash, semicolon, or plus, it will do the same thing. It will actually do the same thing. So at this time, I want to delete those files. Those 2 files, I want to just stay RM. Now this time I run it, it's not there. It's nothing there, but all these files are there. What if I just want to delete all of them? I could use the RM command here with don't have to put any size. This will just print everything. And then I could just say only delete certain ones if I want. I could just say RM here, and then I just did it, empty, the directory. Or I could have just done the same thing with allocate. Let's say, let me see if the for statement, I could just pass it on. Yeah, so in this case, instead of 100, I'm going to create 500 of them. Notice it's going to take a little bit. So sometimes you could do certain things with this, And if you want to play around, you could put some sleep command, date command. That way you can look for these processes and look around what you want to do with the proc file system while it's running, how you check for the process and send it, mail yourself, how that one. Some session, I'm going to explain that one as well for you. But let's say at this time I created all these 500 files. And then notice that some of them were huge. So as we went there, last time it was only 50 meg. Now it's much bigger because any files that are 100 and more, and the size keep growing, 124 meg. And then the next time, if I just do it with more files, it's gonna just create longer. So at this time, let's look at a couple of examples that later on other session I will show you how to check for the processes and other stuff while this is there, the directory. Remember I was doing the find command. The find command that shows a lot of other ways you can play around with certain directory structure. If I'm right here, M2 is there, the contents of there, and then I say, is there a file named file underscore 90? I could just do the like this and say star 90 star, and then that will just give me anything that has 90, but I just don't want the underscore there. So I could just use regular expression here. I could say that underscore 90, it will only show that. So this is regular expression matching here, or I could say it has to have the extension of new is there. But then what if I want to do everything but that 90? So 190, 290, 390, and so on. I could do something like that for saying that, and it has to have one character between 1 through 9, and then followed by that. Now I'm just doing regular expression matching. Don't show me the star underscore 90, but show me everything else that has to have those numbers. So then you can just say while read var do ls minus l $var done. So instead of saying $var, at this time I did not get the actual file name. So right here I had to use, before that one, I had to use awk print $9 because I want to see the file list, file name first, then it shows it. If I just change my ls command to -l to just show that, it will just give the name of the file and that directory. And if I just say, and instead of doing that one, then remove it, it is done that way too. Now I run it, there's no such file there. And my other command right here would also not show any files there. And notice that the output of this command says no such file or directory. If I don't want to see the output of that one, if it is not there, I want to see the output to not provided to me, I could send the standard output to redirect it to dev null. That is telling me that, okay, if it is not there, don't error me out. So like, for example, if I say under the M2, I have to say find dot minus name name star dot new. It's gonna just show all of them. Find my dot minus name star dot new uppercase. It's gonna show all of them. But if I just say the same thing instead of this to etc directory, it's going to just say a lot of permission denied because etc is owned by root. I cannot see those directories. So in order for me not to see the output of that information and still do it, I could say to greater sign standard out dot error. Okay, actually, yeah, std dot error. So the standard error, I'm going to send it to a file called the standard error, and then run this command. Now it did not just error out, but the output that was supposed to be seeing on the screen, it sent it to this file. So now I can see what happened. Oh, I did not have permission. That's there. So another type of redirection you could do is to send it. But what if I want to say send everything that has .conf file? So it shows me all the conf file that are there. The one that are saying permission denied, I don't want to see that. So that's the syntax. You're saying that show me all the conf file, and then the one that are erroring out that I don't have permission, send output to standard error. Or you standard.error. You could see that, you could do this, or you could do this. Send it to dev null. So you don't even want to see it later on. You just send it to nowhere. / dev null is like almost like a black hole. You send it to somewhere that you will never find it back. So at this time, the to greater sign is one way to do it. Okay. What if you want to keep both of them into an output file that later on you will find it? For example, let's say you did this conf file and you say, oh, this is from the command line that are there. I want to see the one that are matching as well as the one that are saying permission denied. Send both of them to an output file that I can get it. So in this case, you do this. You say greater sign my output, my standard error, my standard output. So this is my dot text. This is just all the files that are sending it there that are matching. Okay, and then you say to. If I just do that one by itself, the permissions or in the standard output, the permission denied are coming on the standard error, but the files I'm sending it to my.txt. So if I say my.txt, I have only the what was successful. And now I say, well, in addition to that one, I want to preserve the errors also. And instead of showing it on the screen like this, I want to send both of them to one output file. So I say greater sign my.txt. That tells it that whatever's on the screen that are coming as a standard output, send it to a file called my.txt. In addition to greater sign &1, saying that wherever the output of a standard output, which is my.txt, which is &1, in this case, send the output of a standard error, which is 2. Standard error, redirect that one to a standard output, my.txt. This syntax will not show anything on the screen, but now you have my.txt both as input, a standard output, as well as a standard error are showing. So here is standard output, and then after that one stays the permission denied. You saw the permission denied some of them. So it's intermixed with the permission denied wherever it did not match those ones, like you see here, it's all showing there. Okay, an easy example to show you in another way. Let me say my.txt. So let's say I'm having all the store.txt here, okay? Or store.sh, let's say just a shorter version. I want to do s1.sh. So everything that is start with s, and then let's just say one file, mybc.sh. I want to see that mybc.sh. So if I just say mybc.sh and wahid-text that does not exist, This does not exist. So first one, it says mybc.sh is here, but wahid-text does not exist, right? So let me just make that file not wahid, so just say does not exist. So these two files, one is does not exist, and one is my and .bc. If I touch the file, say does not exist, and then I run the same command here, it will just both of them, right? But now I'm going to remove the does not exist, and I'm going to run this command ls-l. It shows that no such file, but I don't want to see that no such file argument. I want to send that one to somewhere like dev null, to dev null. Now that mybc.sh is there, but dev null, the other error was not there. But if I just want to send that one to a file called d for the does not exist, then I say d is going to just say this file does not exist. Okay, so at this time I'm thinking that I could stop because let me see what's on s6.sh. Sequence 1520 starting with one incremental. Yeah, I actually did this one. Number of directory. Yeah, it's just basically it creates it, it just deletes it afterward. I believe this one. Let me just see it again. And this one, so the new directory, for every directory that it created, then it's going to delete it afterward, removing it there. Let me just remove temp2 first, rm minus rf, temp2. So that's rm minus rf, it did get rid of temp2 and the directory itself. That's a fast way to delete something that you don't want to do it. And then I'm going to run s6.sh. So this one is creating the new dir1. Inside, it's creating file 1, 6, and 11 megabyte. And as it goes create them, then later on it deletes them, removing the same files. With one statement, as you can see, more s6.sh, I'm creating them, and then because I'm using the same sequence within same statement, all I was doing is reverse the opposite of creation and look for the same files with the same name and deletion. And then the name of the directory in this case is new dir1. So if I just go new dir1, it's all clean because afterward it created, it deleted. Okay, so I could write like two different scripts to run it, and you could play around, cut and paste. For example, let me just see one thing here. Copy s6.sh as f.sh. Okay, so this is move f.sh to sc.sh. C for creation. So c.sh. If I just want to create only. To show you the creation, and now I'm going to clear the screen. So cut c.sh. This one on new dir1 is going to create these files, as you can see. So new dir1 is empty right now. Okay, I'm going to run the c.sh. Then I just look for the new dir1, and it created those files. Okay, so this is how simple it is for that syntax c.sh that you did. And now if I just copy S6 um, to $sh to remove r.sh. You make sure that whenever you do these files creation, the same name doesn't exist. I know it doesn't exist. So I'm going to create that one and then r.sh. This time, instead of creation, I'm going to just remove these lines and then remove the r.sh, run the r.sh. So notice that prior to this one, I already created a new one with those files. And now I'm going to show you the r.sh. This one's supposed to clean out. So let's clear the screen again. A new one, and now r.sh. It's deleted. Now go back to same screen and then do ls minus l and empty. As you can see, that new one now is empty because we just created and deleted it. So the thing that I want to show you on the S6 examples is that if you created with this syntax, whether you use the $ brackets or the backtick, the syntax, as long as you are doing logically same kind of condition matching and variable names the same and directory name the same, creation and deletion should be the opposite of each other. Okay, I also want to cover user-defined or how to handle user input. So whenever a user is using your scripts, they provide feedback back to your script interactively. You ask a question, do you want to delete something? Yes, no, and they prompted. Do you want to install something? Yes, no, install. Do you want to just continue? Whatever question they ask, you give them a menu. This is your system administrator that's running certain commands. You just want to provide them a menu and you want to display that. So here's some good example using if statement, while statement, case statement, do, for, and then other select and other things that we could practice with. Obviously, there will be continuation with these examples for the graphic part also, that I'm going to show you how to do it in dialog boxes and how you could do like GNOME or KDE kind of graphic screening that you could just write your script to just display certain dialog box, and then they could input the value. We will practice with a lot of those ones. And I'm hoping that you take these lectures and examples that I gave you seriously, play around with them, because sometimes if I just at the final project, I say, let's write your calculator that you did at as basic, let's write that one to just do similar work on the what do you call it, on the dialog box or GUI interface. You should be able to do the same thing. So at this time, let me see if I have one for a calculator also. Yeah, my basic calculator. I want to show you the BC command on Linux, how you do on Unix, how you do basic calculator. As you can see, basic calculator, I showed you on command line, you could do a lot of things, adding numbers, getting a square root of something like 25. You could get that, and then square root of 100. Square root is a built-in function within BC, so you could get that. You could do power of function with encore symbol, like 2 to the power of 5 is 32, and then to the power of 8, and then to the power of 10. So you could do that. 1024 is 1 kilobyte to the power of 10, and then you could do floating point numbers, 5.5 plus 100. You could do that, and then multiplication, division, a lot of the different type of scaling, and even for statement, while statement. But let me show you a couple of other ways you could do with Bash using similar environment variables. So my basic calculator.sh. Yeah, my basic calculator.sh. So on this one, I'm just showing you some like echo statement. Whenever you do echo these numbers, pipe it to a basic calculator, it's just run it, and then give you that result. So if you do without that one, if you just say, let's say 5 plus 5, and then you just say this, and now you say echo, let me just go 1. The right thing is, with this one is 1, and then put a $sign here to get the result. Command not found. Let's see. Two of them without anything. We'll just do that. No. 5. Oh, sorry. So 5 plus 5. And then I have to use 2 brackets. This always get me on the one of them versus 2. So the plus is not understood because it's not doing calculation. $sign. Let me see what's going on here. Echo 5 plus 5. This will return to basic calculator. We'll do that. But let me see. Echo. Sorry. Expression 5 plus 5. Yeah, the expression would work. And then if I just say echo, this would work. The backtick would work. And then if I just, however, the problem is when you put the digit in floating point numbers, it will not understand. So the way you do the floating point numbers, use the calculator, 5.5, and then use basic calculator. And then I have to do the echo in front of it. So that would do it right. But let me just see why the other argument were not working. 5 plus 5. So if I just say 2, 5 is equal 5 plus, x is equal, yeah. X is equal 5 plus 5. This is an expression. The other one was not. Now I say equal $sign x. Yeah. So that's, you have to use it as an expression. You cannot say 5 plus 5. If you just say 5 plus 5 by itself, and this one will not return anything, but you could say echo on it, and then that does not understand. Let me put that one inside the thing, and doesn't calculate it. Let's see. Wait, one of them does it calculated like this? No. But with backtick, it does understand it like that. Five plus five echo. Oh, expression. Because you have to say echo 5 plus 5 is not a statement. It's not a way to understand. Echo is just echoing the variable. I don't know why I was writing that one. That was the wrong syntax. Okay, so the way you put the variable earlier, like I showed you here, with examples of x. Let's see, what is yeah, like that. You could do 5.5, and it will not get the value because that's a incorrect way of doing it. But if I just send that one to basic calculator and just use this part of it and do echo, that would do it. So basic calculator does that one. Cut my bc.sh. I want to show you this syntax, which is really nice in a quiet mode. You could do a double less than sign, which is almost similar to your cat command with the doc. So when you start with end of file, if you're using the word end of file, you have to close it with the end of file. If you're using other things, you could do that one. So in this case, if I say bz calculator minus q less than sign and I put doc, then I have to do doc again. Square root of 100 and then a square root of 50, let's say 25, and then 2 to the power of 7, which is 128, and then doc here, it just shows that. So this is a good example of doing whatever start with. You could do multiple calculation and you get the result for each one of them. But if you assign it to a variable, okay, my bc.sh, and here I'm just using a variable, okay? In this case, notice the brackets that I'm using. So I'm putting that variable into a dollar sign. And then I'm putting echo 5 plus 5 basic calculator. And then here I do the same thing with that and then print it. So let's try that one. My variable in this case is x is equal. I'm going to say dollar sign and then start echo 5.9 plus 10 and then do a basic calculator and then that will just give me echo dollar sign x. It will just give me the summation of them. So that's a syntax that accepted inside the bracket, inside the parentheses with dollar sign one parentheses. And then you assign the value of the whole thing to an x. Earlier, what I was doing here, instead of doing that, I was doing an echo, which is the same thing, but I was not putting this one, and I was not using the basic calculator. So the right syntax is to use this, and then that, whether you do it with echo or assign it to a variable and then print the variable, it will work. The same thing. So that's for floating point numbers. Another way that I'm doing here is that x is assigned to the dollar sign parentheses basic calculator in the file. So in this case, I want to get the value of square root of that, which is 4. 4 times 4 is 16, square root of 16 is 4. So if I just use that syntax, x is equal dollar sign, and instead of basic calculator, if I just say end of file, and then do a square root of, let's say, 11 times 11, which is 121. And then the square root of that one is back 11. So I'm going to get the 11 result. And then close it. And then echo $x should give me 11. Same thing if I just use that 25, 5 and 5, it should give me 25. 25 times 25 is 625, but the square root of that one is going to give me back 25. And if I just say basic calculator, 25 plus 20 times 25 is 625. So, and then I say square root of 625 is obviously 25. So a lot of the scripting that you do, you could write these functions to do the calculation. Like the first one, I was writing you multiplication, summation, addition, division, and then here's your basic calculator for floating point numbers. If you write them to make them functions, you basically finish the entire midterm project. Even though some of you have not submitted, here's your chance to look at these ones and finish it up and make sure that you're done with the assignment. Because some of you guys are not even halfway, some of you are 100% done. So I want to help you out if you are in need of just getting it done. Please work on it. And then finish it out by this Thursday, the latest. Hopefully you will be done by Thursday and no more time, because I want to give more assignment on Thursday after that. So no assignment tonight, but work on these labs activity. I've been talking since 6:30, and it's almost 10 o'clock now. I'm gonna show you one more script here. Let me just get out of here and then do handling user input. So on handling user input, I want to show you this script called 7.sh. And this one, I'm just basically writing a system admin menu. And this sysadmin menu, as you can see, I'm formatting it to do some tabs to just show the data or the menu on the middle of the screen. So that's how you do it. And then here I could do this, the one that I'm commenting out. Sometimes you could use with the echo statement to go particular lines, and sometimes you could use the read -n. And then in this case, I'm just tabbing it a few lines, so it's 0 is matching the 6 here. And then later on, it's gonna get -n1 opt. This syntax is saying that read only one character, -n, maximum of one character. And the read statement that I'm doing there. So the OPT is the variable that I want to see what the operation that the user wants to do. So in this case, I'm using the while statement. While normally is while true or while one is meaning that it's always true. So in this case, it will go to an infinite loop because that one is never gonna go false. But when the user type in 0, I want to break out of the loop. So inside here, I'm using a case statement. The menu is this function that I'm having here, function menu. So while true, call the menu function. It is going to display the menu on the screen. Then it waits for the user to input for OPT. It reads the OPT value here. And then let me just go with set line number, set NU. So on line number 21, it reads the OPT. And then once it comes out case OPT, and one it does a hostname Ctl command. And then all of these ones you could be written with functions with more arguments, or just add on more argument. Like for example, if you want to just say, show me host name, just do that. Show me uname minus a, do that. Whatever command you want to do, like if you want to say, show me the uptime of the system, do that. Send me a netstat minus a and show me a lot of the commands. Vmstat minus a whatever, or vmstat 10, 1, and so on. So let's say iostat, vmstat. As you commands, you could just run a list of them. Here I'm showing you the CPU, LS CPU, so I know what kind of CPU I have with the number of sockets that's connected to the CPU. Here I'm looking at the CPU info and the proc file system, which is the pseudo file system. Even though when you list this file, it shows 0 byte, but when you read the content of it, it's reading from memory. So it will show you what's in the CPU information, how many CPUs you have, what kind of architecture it is, how fast it is, and so on. And then memory information, for memory information, the same thing. There's like, for example, let's say you did this meminfo and you want to just run free command. And then you could do free and human readable minus h or dash dash human. You could do a lot of commands like the df command, dh command. This is just a list of these ones. Like if I just want an addition to this one, say system ctl status, let's say NTPD, and this is that timing protocol, or add-d or cron-d if there's any cron job that is running. So you could do a lot of those ones to see the status. And then top, if you're running top or PRstat or VMstat, IOstat, a lot of these things you could do. You can run df minus h and look at the file system. There's so many things, so you could just play around. But notice when I do the 0, I break out of the loop. So everything else that the user provided, just say either provide 1 through 6, and then if you add on a number 7, make sure that you modify these variable. It's good to have these ones defined on the top of your script, so you modify it once and you're done with it. So if I just run a 7.sh, and it's going to give me that menu. So this is user input, how you handle the user input. If I just press 0, it exits out, say, okay, you selected to exit out, that's it. So your script should not go to infinite loop, even though it is going to print the menu every time I use it. For example, I type in 1, it runs the command, as you can see. For each of the command that I listed, it run each one of them. And then since the command is a long list for each command it runs, so it makes sense that if you write them in functions and then we'll just clean it up a little bit to say the user should see better input. Like for example, let's say I do 2, it's going to show me the commands that I need to do for CPU, list of CPU, and like it says CPU megahertz is this, and then the hypervisor, and this one is KVM, and then and so on, socket, and the number of cache and everything. So if I press any key, now it goes to show the CPU details, like cut proc CPU info. So if I just run this command, it basically shows you the CPU detail. And then if I memory info 4, it just shows you the memory. And then notice that memory cut memory total is showing like 1.8 gig that is available for this system, because originally I have 8 gig on this laptop, and then I just allocate for HVM about 2 gig or something to just play around with it. That's fast enough to do what I want to do. And then the free command, for example, here shows memory in terms of a human readable, you see 1.8 gig, where I was just reading it. And then how much is used, how much is free, and so on. And then swap space. So if I just go to number 5, and this is system units with system Ctl command. And then I just added with cron D at the end of this. Let's see if that one shows up. Yeah, 48 unit files, and then quit out of that, and then here unit files, press any key to continue, and show me the output of number 6, top command. Top is going to basically give you this. And top is really cool for system administrator and users to know what's activity is happening. Normally, top or htop is the graphical version of this one, not graphic, actually colorful version of top commands, but they all give you good detail of how the CPU is utilized, how memory is utilized, swap space, what part of the CPU is the user part. Like right here, it says 1.0 US. US means users. SY is system. And I is for nice. ID is the identification, and wait time, and high semaphores. There's a lot of details in there for memory, for example, how much is used total, how much is used, how much is free, how much is in the cache, and so on, and the kernel swap space. This one, it says 0 zombie. That means there's no zombie process on the system. That's a good thing. When the process normally dies, because the parent forks a child process, and the child process dies for whatever reason, or the parent dies and the child becomes orphan, the child normally becomes orphan. The parent, when it dies, the parent process ID is no longer available for the system. And normally when the parent forks a child process, it tells the child, go on my behalf and do this task, finish this task. And when you come back, I'll close you as, okay, you're done. But before you do that one, it just kind of like gave up his life for the child process. Say, go ahead as me with my parent process ID and all the resource that you need, use my credit card, in this case, my process ID to the system, give it to the init, which is the mother of all processes. And then if you need a resource, like you're buying something, in this case, you're not buying anything with that credit card of my process ID, you're just basically using resource. In this case, compared to a buy, imagine the user needs memory, and it needs I/O, it needs CPU time. All of those ones, it uses its parent's process ID to ask the kernel to say, okay, here's the process ID, which is my equivalent to my credit card of my parent, and just give me the resource I need. Then at this time, the resources are going to be allocated by root, which is a higher level privilege, talk with the device drivers, and then give the user the needs that are there, the process of the child process. And once it's done, it's gonna terminate. But at some point, sometimes on the system, the root, I'm sorry, not the root, the parent process ID dies, and they have a child process that become defunct. It's not knowing how to allocate, which credit card it should use, which process, parent process ID should use in order to do it. So the init, which is the parent process ID of 1, which we call it the mother of all processes, is going to adopt that child, orphan child, that is dangling on the system like a defunct process that later on, if init cannot clear it from symbol tables, is going to become a zombie process. And normally on zombie process, when they become the zombie process on some system, it is much harder to clean it up if there's so many of them, because the system is already in degraded mode. So as a system administrator, normally you want to get rid of the defunct process and identify all the child process that needs attention, whether they need I/O or a resource. Sometimes if the user is not giving the input, like in this case, I'm just talking and I'm not giving the input, my script will be just running in that state forever till I just say quit out of it or just use it. And at some point, those resources will be just keep allocated for that process till it is done. So and the process dies on the parent process, and it is going to try to help it to clear the symbol table and says, okay, this process is now done. All the resource that it was there that was requested, I give it to it, and it's no I/O bound anymore, no CPU bound, no memory bound. Now I'm going to close that process, and that process gets closed successfully. And if it doesn't get closed successfully, they become like a zombie process. Then on Solaris operating system, which is really, really a cool operating system, I really like it. And there's a lot of tools that allows you to do things that are normally not handled by Linux operating system, for example. Linux operating system, if you have so many defunct processes, most of the system admins and most of the senior people, they just say, oh, in this case, there's no other things but reboot the system. Yeah, reboot is just the last resort. You don't want to reboot a production system just because you have 10 zombie processes that you should have taken care of it originally that you forgot or you did not get it on that system. The right thing to do is to do a preep command. Preep command on Solaris, it clears the symbol tables, it does all the neat things for it, and it just clears it. And you could also identify the parent process ID for it, for that defunct process. If you get rid of the parent process ID, then you could do it. I have worked on a lot of Linux machine that there were maybe 23 zombie process on the system at one point, but as I had identified with LSOF and all F users and other commands that you do, I was able to just take care of the problem without any user impact, any system downtime or anything. You just basically get rid of those processes that are supposed to be dangling on the system. They are not anything, but they're just slowing down your performance. And then maybe just consuming some of the memory or some of the space or swap space or something that is on the system. You just want to get rid of them before it's too late. So this is nice that you have these features. Like here, you can see PID, process ID, the ownership of the user, priority, how the process starts. Normally, every process that are running on a system, you have a priority level. The highest priority is -19, and then the lowest is 20. So the lower the number, the higher the priority in Unix. That's how they say. They always say the nice man or the nice guy finish last, that expression. So it's similar to that one. So if you see some of the root higher priority, like in this case, the kernel stuff is what, -20. Watchdog is -20, or some other processor that init is a higher process. So the one that are lower process, by default on the average, every process starts with process ID of 0. And then you could also use a command called renice. By renicing it, you have to have a root privilege or sudo privilege to renice it. Other than that, you can only lower the nice priority level, but you cannot go higher level. So when you do the renice, sometimes depending on your privilege, you could renice a process to run with a higher privilege as long as you have root access to the system. And then by doing that one, it's just give you more CPU, more memory, and just higher priority to run. As you can see, the last top 20 commands are running here. X and MySQLD and other ones are just keep coming there as processes that are being forked. even though I'm not doing anything particular on my Ctl, but I installed it and I could play around with it. I really like Oracle and MySQL and database stuff. I taught a lot of classes in the MySQL database in Oracle, and I built a lot of systems and that work with database extensively. So I want to just remember all those syntax and things that I did with the data definition language, data manipulation language, data control language, primary key, foreign key, all those kind of concept normalization, which is on the part of the database that's really extensive. I did a lot of work on that. So um, someday maybe we have a class that I could teach you my SQL stuff also. But at this time, let's just look at the next column, the virtual. The virtual memory is an area of memory that's virtual. As you can see, the word virtual is not physical. The resident portion is the area of the memory that the binaries are getting a resident part of the memory is always there. So the binary, there's a portion of the data before the heap section. The actually program, when you run a program, when it gets loaded, that's the resident portion that resides on the main part of the memory. And then the shared memory is the memory that are shared among other resources, or sometimes .so file, the shared object files, sometimes DLL files, dynamic link libraries. They are shared based on certain libraries that are written for that purpose in order to make a function call within a library. And if the function was written in such a way that it could print a file, a name, and then the contents of that function was a shared object within that shared SSO file, SO file, so a library file, a dynamic library file. That function will be loaded into memory once because it's shared. Every other user could spawn on that function, and then they could give 1,000 file names or 10 file name. They could print using that function. All it is doing is the name of the file will change. So the S, I think it is static or a resident portion. I don't recall that one exactly if that is the case. And the status, whether it's running or stopped, or in suspended mode or something. Running or so at 1 minute or a nanosecond, a process, when it gets on CPU time, it only shows the process that are getting a CPU time at runtime there. Because it's real-time CPU, it is just really in nanoseconds, so it's not going to show 10 process in running state, even though they all say, when you check for it, it says these processes are up and running. But whether they get CPU time or memory time, it's just the top program that gets loaded there is there. The CPU time and memory time is showing, and then the time, how much time this process has taken. So like that one, my Ctl has been running in the past 2 hours and 25 minutes and 1 second, and so on. And the X session is for 4 hours. Some of other commands. So the actual command is the last one. You could do a lot of other syntax here. You could just check it by users. You could do every other syntax, but I'm not gonna show you too much on top. I'm gonna exit out of here so we can finish this session and do the last one. The only difference between S7 and S8, S7 is written in shell, bash shell with while statement, and S8 is using until statement. Everything else is the same. So as you can see with until, like I told you, the syntax has to be false first. And then somewhere in the syntax, so you're going to say opt is equal 1, which is then you compare, say, is up exit 0. If it's not 0, then enter the menu. So it's going to display the menu and it's going to do it. So I'm going to just run this one more time with S8. And again, the syntax of until, later on this 0 becomes true, it is going to break out of that one and then end it and then done with the ESAC. So at this time, if I just say 0, it becomes true. If I just run it with, let's say, I want to do the number 6 again with top and quit there, and then I could say number 4 or 5, show systems, and then Q for out of this one and there, and then I'm gonna exit out. So one more last things I'm gonna show you is 8. And then as you can see, the menu, the functions is the same. In this case, I'm doing an until statement with initially this being false, and then later on, when the menu is displayed, the user provide 0 for quitting, and then that's when the statement is break is going to be executed. Break is going to break out of the while or until statement. In this case, the outer loop, and it's going to end. Okay, so I'm going to stop at it's 10:17 already, past way of everything. So I'm going to stop. I'm hoping that my recording will go fine. That way I can just have this one posted for you guys. Let me just stop sharing and stop recording.